All right. Hey, everyone. Welcome back to another episode of the Sourcegraph Podcast. So a couple months back, I started noticing my teammate, Stephen, tweeting about this thing called Zig. And at first, I didn't make much of it because Stephen is a brilliant programmer who's built a lot of the core functionality up and down the stack at Sourcegraph, who also likes to pursue a lot of side projects, ranging from hacking on search backends and indexing technology to building miniature castles for his many, many cats at his home. But then he kept tweeting about this and all the cool stuff that he's building in Zig. And so I decided to take a closer look. And upon taking that closer look, I found a really cool programming language that was new to me and a really awesome kind of early community around it. And Zig is this kind of systems programming language intended to replace C. And I'm really glad today to be joined by Stephen and also the creator of the Zig programming language and the founder and president of the Zig Software Foundation, Andrew Kelley. Andrew, thanks so much for being with us today.
Hey, thanks for having me on the podcast.
Cool. And hey, Stephen, thanks for joining as well.
Yeah, excited to be here.
Cool. So, before we dive into all things Zig, I just want to ask Andrew, what was it that got you into programming in the first place? What started this kind of, big journey for you?
I think I have a pretty average story. I was a young child. I liked video games, and I especially liked the ones where you could, make your own level or something.
Yeah.
I remember for me, Tony Hawk's Pro Skater 2 was a magic experience. You're making your little rail gaps and naming them and all that stuff. And so when I discovered programming, it was the ultimate game. It's make your own game, right?
Yeah.
So I think that's how it's just like the appeal of the power that you could have over the computer.
Yeah.
I think was what got me into it.
Did you start programming games, or was it just kind of that general concept and then you got into programming in a different domain?
The very, very first thing I did was, I think it was Intro to Programming for Dummies or something. I was 12, and it came with a it came with a Liberty Basic CD. Just like this language no one's heard of. It wasn't good. It was just like someone's project to teach programming with a basic language.
Awesome.
And so the games I made were basically just dialogue trees. Like, what's your name? And they're like, oh, hi name. Like, do you want to go north or east or?
Got it. Yeah, Stephen, I think you got into programming a lot through video games too, right? If I recall correctly.
Yeah, definitely. Okay. I remember, I think my earliest stuff was trying to make games in CSS, and CSS was not very well versed for that at the time.
Games in CSS. That's
yeah. It was.
It's very functional.
Yeah.
Functional in the programming language sense, maybe not so functional right. From trying to get game logic in there.
Yeah, fair distinction.
Yeah,
cool.
Yep.
So okay, Andrew, from that kind of early beginnings, what was the path to Zig? Was it always in the cards for you that you wanted to create a programming language, or was it more windy and circuitous?
Well, I was just fascinated with every topic of computers. So I remember, shortly after I got out of the Liberty Basic, I found Visual Basic, Visual Basic 6 to be specific, and I loved it. The fact that you open the program, it just gives you a new project, as every application did back in the day.
Yeah.
And you could just press run right away, and an empty form would come up, and it would say form 1, and there'd be nothing on it. And yeah. It's just an invitation, right? To just drag something onto the form and just create something.
Yeah.
So I really enjoyed playing with Visual Basic, and I just tackled everything I could think of. I wanted to make a WYSIWYG website editor. I wanted to make games. I wanted to make utilities. Anytime I wanted to make macros to move the mouse and click for you. Anything I could think of, I was transfixed by the magic of just being able to make the computer do what you want.
Yeah.
So I had this huge folder just full of all my little experiments.
Cool. When did you get into C development?
Pretty late in my career, actually.
Okay.
So I think, the difference in what I was interested, there was a big difference in what I was interested in and what I could get paid to do in my career. And as I kind of got further along, I realized that some of the projects I wanted to pursue, I would need even more control over the computer. I couldn't use Python or Perl or JavaScript or something, because I really needed to reach into the operating system and use the low level interfaces.
Yeah.
Maybe to detect like a MIDI keyboard, or just like if you're trying to explore everything you can do with a computer, eventually you're going to have to reach into C, and so that's kind of how that happened.
Right. Because C is kind of the like closest to the operating system and the lower level, I guess, like functions.
Did you jump straight to C from these higher level languages, or was there kind of like a struggling in between period?
I definitely learned higher level languages first, and then I think just in college I wanted to learn C just because it seemed like this powerful tool that I could add to my toolbox. But I definitely came from the top down and had to learn, what's really going on underneath all these abstractions.
Yeah,
got it. You were at OkCupid as an engineer for a while. Were you working? What languages were you working on when you were there? Was it C or more like higher level application stuff?
That was a C++ code base with a twist.
Interesting. Ooh.
They had their own preprocessor.
What?
That ran before the C++ preprocessor. Oh yeah. It was called.
Say more.
Yeah, because C++ needs more features, right?
Yeah.
It's known for not having enough features. So it's called tame. I forget why it was called tame, but
okay.
So you take the tame file and it added a new syntax to C++ to do asynchronous stuff, and then it would output C++ generated code, and that's what you would compile.
Wow. Yeah, that's almost on brand for OkCupid, at least what I know, and I know very little, but like my impression, it's like a dating application, but it was started by what appear to be like more like system Z or like language nerdy like programmers out of MIT. Is that
yeah? Not only that, yeah, that's completely true, and not only that, but there's a public research paper you can go read called OK Web Server.
Yeah.
And the business is actually named after that paper, not the other way around.
Got it. So very analytical minds at this company.
Yeah, they definitely had a lot of fun with technology. I would say even more fun. Like I would say they even prioritized that more than the business senses in the beginning.
Yeah.
Before the suits took over.
Got it. Okay, cool. So you were at OkCupid. Was it at OkCupid when you first started to think about Zig, or what was the origin story behind the Zig project?
I was actually already 3 years deep by then.
Okay.
So
this starts way before that.
Oh yeah. I would even describe and I've said this in other places, but I think it's a nice analogy. I've described the Zig project as the flowers growing in the cracks of cement of my career. So, I mean, I've always loved just research projects and just pursuing just learning for the sake of learning, and I want to do programming for fun because I just love it as a hobby.
Yeah.
So my pattern in my career has always been save up a bunch of money, quit, take time off to play with side projects, run out of money, get a job, save money. That's the pattern.
Yeah.
So I started Zig actually 6 years ago now. And I actually had spent an entire year unemployed working full-time on Zig for fun before I went to OkCupid.
Got it. So what got you like working on Zig in the first place? Like, were you at another company at the time, or was it during one of your kind of off periods when you were doing, more exploratory work? What was? Can you trace it back to like a particular, inspiration point or motivator, I guess?
Yeah, I sure can. I was working on. I had taken a year off work, and my goal was to not bounce around between a bunch of small projects, but to stick with one, and see it through longer, and get the experience of working on a project for a longer period of time.
Mm-hmm.
There's trade-offs with doing that, and I hadn't tried that before. I wanted that experience.
Yeah.
But the project I was doing that with was a digital audio workstation. I still have that project, but it's not. It's obviously on ice at this point. But someday I'll pick it back up.
Yeah.
But I just kept in the back of my head. I just kept having this little thought, like, oh, but this programming language C++ is not. It's not a good tool for this job. Like we need a better language to write this music studio with.
And so you started work on Zig. Was it like what did V0 of Zig look like? Did you get to the point where it was functional and you started using it for this other project?
I think I did play with that a little bit, but it's not to that point yet. I don't think I would seriously use it for that project until we ship the self-hosted compiler. I think that's the point when it's time to start trying it out for big projects. Got
it. Cool. What's been kind of like the overall like life cycle of the project so far? So it started back in what year did it start in?
Can I look it up real quick?
Yeah, sure.
All right, here's some keyboard typing for you. I'm just running git log and going to the bottom. All right, first commit is August 5th, 2015.
August 5th, 2015. Okay, so you started then, and then somewhere in there you ran out of money, you got a job at OkCupid. I assume development continued.
There was actually another company in between there too.
Oh,
so
wow,
I got a job at Backtrace, another startup.
Cool. And all this time you're just hacking on Zig on kind of the side, like nights and weekends, that sort of thing?
Yep. And that was pretty stressful. It's having a full-time job is already a drain, and trying to work on a programming language on nights and weekends is it's taxing, and it comes at a cost of health and social ability to socialize and all these things.
Yeah, I mean that's a huge drain. Like one big commitment or project is enough, and these are two like massive big projects. Do you have any like lessons or words of advice for other folks out there who might be in a similar situation? Like, hey, I want to pursue this thing on the side, but I also don't want to give up the main thing I'm doing.
Yeah, well, I don't regret it. It's everyone's job to figure out how to find their own meaning in their life. But in terms of trying to be healthier, I would say it might be easier than you think to try to get funding for your hobbies. I think that as programmers, we're pretty lucky for a few reasons. So one is that we can acquire savings pretty fast. Like we can get compensated pretty well at this point. The mechanisms of capitalism haven't figured out to exploit our labor yet. We're still on top. But but also like the work that we create, many people benefit, right? So a small number of developers can create software, and then a lot of users can benefit. And that equation, it's kind of like Big O, right? That equation is actually also the equation for making money. If you can do a little bit of work, but then a lot of people benefit, that's and everyone just gives you a little bit of money, then you're actually golden.
Yeah.
So in getting donations is it's not lucrative, right? Like it's not a very small percent of people will give you money.
Yeah.
But the point is that because you can give software to so many people with only one person who needs to get paid, or a small number of people who need to get paid.
Yep.
The numbers do work out okay, for a lot of cases. So I guess my advice is just maybe consider that you might be able to if you get creative, you might be able to make it work. You might be able to swing it without a job.
I was just going to ask, how long did you like work on Zig, as this kind of like side project, hobby project thing before, it got to a point where you were like, oh, we're getting enough donations that this is something that I can like switch over to full time?
Well, at first it was people donating to me directly. So the Zig Software Foundation comes in at a much later point. So there was, so at first it was Patreon only. They take 10% of your money, which is wild to me, but that was the best I could do at the time. But you can kind of see the trends. It goes, and for me it was going up with every month, and it helped if I did blog posts, and when I did releases with detailed release notes, that helped too. And wait, what was your question again? Sorry.
Just like how long of a period of time was that before, it kind of like clicked for you that like, hey, actually, I can make a living off of, kind of working on Zig and that sort of thing.
Right. So I was working at OkCupid and I was crunching the numbers, and I realized, okay, I have this much savings. I have this much donations per month, and it's going up at this rate, like as a conservative guess. And then I figured out, oh, wow, if I quit now, my savings go down, but before they hit zero, they start going back up. And that was, I think, 2 years ago. I have a blog post that has a date on it that I can check to find out the exact time.
So it was a pretty gradual kind of thing over time. It wasn't necessarily something that was sudden. Okay.
Yeah, as far as monetary growth of donations and just in general participation in the project in any form, pull request, issues, money, it's all been very gradual. There was never a point where it just exploded.
Can you talk about the technical evolution of the language from its inception in 2015, up to the point where you started working full time on it? How did it evolve in that time period?
Yeah, that's a good question. What are some examples of the kind of technical, structure that you're asking about?
Like I imagine, there's a lot of cool language features now. Like compile time, code execution, and like the memory allocation. The kind of async await, like all these things. I assume that they didn't all get added at once, or maybe they did. Like, was there kind of an incremental exploration process? How did the spec of the language as it stands today, like, kind of come into focus over time?
Yeah, that makes sense. What you're asking. Yeah, it was definitely incremental, and I've been developing it open source since the very beginning. So it was very rare that there was a big unmerged branch. It was all. I like to get the code just in use as soon as possible, so that you don't have just bit rotting code sitting around.
Yeah.
But anyway, to address the question more directly, the vision that I've had for the project has been very consistent since the beginning. But my attention, motivation, energy has just bounced around across all the different aspects of it.
Yeah.
And I'm pretty happy with that, actually, because I think that managing your motivation and energy levels is a meta skill that is just completely core to what we do.
Yeah.
To have a successful project. But I also realized that it actually helps with contributors, because I kind of think of it like creating a skeleton where you can kind of reveal your vision by doing a proof of concept. And if people like the vision, but they want to contribute, they see the skeleton and they say, oh, I see what we're doing here. I can fill in some of this muscle and, do the rest of this work. So I think, just kind of bouncing around wildly between different aspects of what I wanted to accomplish has actually been a valuable asset. So it both helps my motivation to stay fresh, and then also just helps people to see the vision and see what the goal is, and help fill in the pieces.
Yeah.
But there's been a lot of things that have been reworked. So almost every language design decision is not the first state. like all my intuitions were wrong. Like all my implementations were wrong. Like everything was wrong. Like the whole project has been an exercise in humility and like paying attention to what's not working and like reconsidering how something should be, and then just trying something else.
How much of that was like an iterative process where you really had to like go and experiment on something and try something before you would even be able to see what the right solution there looked like, versus like being able to design it up front and really reason about it up front, that sort of thing?
I think nearly everything was iterative. So it's all just been guess and check. Like, I think that this language feature will be a good idea. Let's try it. And then I did it. And then I just observed how it affected my experience with the language and other people's experiences with the language. So it's pretty fast paced, pretty chaotic, pretty disruptive to trying to actually use the language. But really lets us explore some ambitious ideas, some experiments that if you take a more measured approach, you just wouldn't really get the actual feedback of trying it. I would say that one feature that had to be a bit more designed was probably the async function feature. The way that Zig has async await. I got it. So the first thing I tried to do for that one was base it on LLVM's coroutine support, and that helped me. So and it's the same thing, right? I just had the idea, I shipped it, we tried it, and there were just so many problems with it. But doing the first version that didn't work very well helped me to understand the problem domain. And so when I went back in for a design iteration, I was much more like that. My second guess was much more on point, right? Because we had tried this other thing, and at least I understood why it wasn't a good idea.
Very cool. Maybe it'd be good to jump into the language features and what makes Zig unique and how it compares to C, just so folks get a sense of how the language feels and what the developer experience is like.
Yeah, I would say that if you are familiar with C, you already know Zig, and you're gonna breeze through the language reference and just map the concepts one-to-one with each other. The differences that you'll find are kind of, I don't know, philosophical differences, just differences in the details of how certain problems are solved, specifically with conditional compilation. So the one thing that C programmers are going to run into is they're going to think, oh, I want a preprocessor here, and they're going to find that doesn't exist. There's a different tool to solve this problem, and it's running code at compile time.
Talk a bit more about that. So, when what I recall from my C programming days, there are a lot of, pound defines and if defs and that sort of thing. That's all the preprocessor. So if I recall, that's like mostly for cross-platform builds, or if you're building for this OS or that OS, you build different code.
Right.
What, how is conditional compilation different from that?
Right. Well, if you don't mind, I'll get a little Socratic method on you there.
Yeah.
So, why use pound define and not a constant?
Why use pound define and not a constant? I think the short answer is that that's just what every other piece of code in the code base I was contributing to did. I don't think I really.
Why though?
I don't really think I thought about it too hard. Yeah, I guess maybe originally it was an efficiency thing, because the pound define, it gets stripped away, and the constant just gets embedded directly in the binary. Is that the reason? I don't actually know.
That would happen for just constants as well, so that wouldn't be it. I'll tell you what the answer is. The answer is because if you try to use a constant in a place that you'd expect to be able to use it, for example, just the length of an array, it won't work. It will give you a compile error.
Interesting. Oh, because C arrays have to be, what's the phrase? There's statically lengthed, or the length has to be known at compile time, and the compiler is not smart enough to draw that inference. Okay.
but it's a constant, right? So don't you think
Yeah,
you should know?
yeah. Why doesn't it do that?
Yeah. So in Zig, we just fixed that, so it works. That's it. That's the difference.
Got it.
But then so the argument that I make is that if you follow this reasoning, right, and we take it a little further, like, yeah, I can ask more questions like, well, why this? And the answer is always something like, well, because if you don't, then something stupid like that happens, right? If you just fix all these like nonsense things, you don't need the preprocessor.
Okay, so a lot of it is just like fixing paper cuts and foot guns in C.
Exactly.
Got it.
So specifically,
yeah.
you mentioned conditional compilation, right? So you might put if def, Windows.
Yeah.
Here's the Windows code. Else here's the POSIX code or something.
Yeah.
So in Zig, that's just an if statement. It's if Windows, Windows code. Else POSIX code. And the key distinction is that it's important to Zig if the condition of an if statement is compile time known. And in this case, it will not evaluate the dead branch. So you can put compile errors in the dead branch of an if statement, and they won't be revealed because the branch is dead. So that's how conditional compilation works.
Got it. So that's
it. That was the two reasons you needed the preprocessor in C.
And then I guess like, in C++, the preprocessor does a bit more. Like they have like the whole like generics thing implemented through the preprocessor. But Zig has its own templates. Sorry, I get a little bit loose with the terminology there. But C++ templates in lieu of generics. And my understanding is Zig has generics built in. So there goes another reason for...
Yeah, it does, but it's kind of the same concept. So we already had this concept of if an expression is compile time known. And so all I had to do was just add the ability to make that true for a parameter.
Yeah.
And then that's it. That's templates.
Say that again.
You just have a function where one or more of the parameters are declared that they have to be compile time known.
I see.
And that's it. You just have a function where you know one of the parameters at compile time, and that parameter could be like a type, for example. You could pass in I32 or something like that.
I see.
So generics in Zig are just parameters that you just know the value of at compile time.
Cool. That's pretty elegant.
Yeah, that's what I'm saying. So a lot of I feel like a lot of the language design is just like, well, let's just fix the warts of C. Yeah. And then generics just fell onto my lap.
Huh. Stephen, when you came to Zig, had you done a lot of C and C++ prior to that?
C++ definitely not. I've stayed far away from that. C, yeah, I've worked a lot with C. For me, the really elegant thing here is just that, like, starting out and trying Zig, like, I was able to get to a position where I was productive really quickly. And that hasn't been true for a lot of languages that I've played around with. And I think that that kind of, the compile time stuff, it was, when I ran across it, I was like, oh, that's kind of interesting. I don't know how I feel about that yet. And then kind of stumbling across, like, oh, here's this really natural extension to what you've already learned. Like, now if you want to, make a generic data structure, you write this in the exact same way that you were writing some Zig code just a minute ago. That feels like a very natural, like, learning curve from my perspective.
So it was super easy to get up and running. Like, how would you compare the new developer experience for Zig to language? I guess like the two things that come to mind for me are like Go and Rust, because they're both in kind of this like proximity to C, C++. Maybe some people might take issue with that characterization, but like, yeah, like how would you compare to the onboarding experience to those two languages?
So for me, and I have a background in Go with like, I don't know, I've worked in Go since 1.0 was released at least. Is very similar. I think from my standpoint, it was very easy to quickly become productive in it, in a similar way that I think most people can pick up Go in, a week or something like that, and start to make changes and get an idea for what that looks like. Mm-hmm. I think the difference for me, where it kind of like differs from like a Go onboarding experience, is like, once you reach the end of that, it's like, oh, well, hey, I'd like to take a look at, I'd really like to be able to express this. And I think, with like the comp time stuff, that becomes a very natural extension of exactly what you've already learned, because it's like, oh, okay, I just need to, pass in this data type here. And then, I get a struct that has this data type as a field or something. That sort of flow is very natural. Whereas I think in a lot of other languages, that's kind of stacked on top, and it's a very distinct system. Like, I imagine people starting out in C could probably, get an idea of basic compilation there and stuff, and then find, oh, like, how do I really, start to use this whole preprocessor system? And I imagine the same thing's true of C++, but I don't know for sure.
It's interesting that generics just kind of grew out of, conditional compilation, and it sounds like they just kind of fell out of that. Contrast that to the experience in the Go community, where, that community has been discussing generics, it feels like, for the better part of the last 5 years or so. So that's awesome. Were there any other kind of like elegant things that, kind of emerged from, I guess, just like core starting principles?
I think that generics is the best example of this, but I feel like some things have been this pattern to a lesser extent. Maybe another example would be it's more of a convention thing, but in Zig, we don't have a global allocator. If you want memory, you have to pass an allocator parameter around.
Interesting.
And there's a few reasons to do this, but just touching on the part where it kind of something else falls into your lap. Mm-hmm. This, combined with the fact that anything that you don't use is not analyzed, so Zig is lazy with respect to top level declarations. It means that you can use the standard library everywhere in kernels, embedded development. If you need to swap out an allocator, or it gave us the ability to make Zig so much more versatile in all these different use cases.
So let me translate that to like, noob brain for a moment. So what you're saying is, like, in C, it'd be hard to take a dependency on the standard library in all these different situations, because you'd be pulling in the entire standard library, and in some cases, like, it just wouldn't run properly on some of these platforms. But like with
exactly. Okay. So for example, if you just kind of naively took C, and you tried to make an operating system kernel, you probably try to include string.h just because you want to move some memory around or something. Yeah. Not found. You don't get it because you're making an operating system.
Yeah.
But why though? You can manipulate strings in memory in the kernel. That works fine. So why can't you import string.h?
Why can't you? I feel like you're taking me back to like sophomore year of college right now, where you're just like sitting in the lab and you're like, oh, how hard could this C thing be? Like, you just like include, files if you want to import functions. Okay, string.h, that seems like a thing that should be importable, and then you get a obscure compiler error.
So to a large extent, the Zig project for me was kind of peeling off these abstraction layers that we've all taken for granted, and just kind of examining their foundational premises and saying, is that really how it has to work? Like, let's question some of this stuff. Like, maybe it can be better.
Cool. You also have this rule of like, there's no hidden control flow, no hidden memory allocations, no preprocessor, of course, no macros. How has that kind of like played out for you? Has that caused any sort of like tensions along the way, like these things that are presumably added to C and other languages because someone found use for them? You've taken them out. How's that going?
I think that that philosophy has been a hardline stance since the very beginning. I mean, that philosophy just defines the vision of Zig, and it's what it's the Harry Potter sorting hat of people who visit the Zig homepage, right? Like, if you read this and you think, oh, good, you become a Zig programmer. And if you read that and you think that doesn't make sense, I want those things, then you don't become a Zig programmer. You know what I mean?
Yeah. Makes sense. To me, I've written a lot of Go. It kind of reflects a certain like ethos in the Go community too, which is like explicit over implicit. Don't do anything magical.
Same energy with Go, definitely.
Yeah. I actually, can we revisit the memory allocation question real quick? I just want to make sure I understand and like listeners understand. You're saying you're passing in an allocator, so there's no global like malloc function that like everyone uses. You pass in an allocator, so you can actually, presumably these different allocators have like different memory management algorithms in place. Is that the idea?
Yeah, that's the idea.
Okay.
And I didn't even think about all the benefits that this would bring at first, but we've just been stumbling on more and more benefits over time. So the example I was giving earlier, I'll be more specific. So let's say that you have a hash map data structure. And it's a great implementation. We have we have an array hash map, which keeps the order of keys. We have I think it's called Swiss tables or something implementation if you don't need key order, and it's really efficient. I'm really happy with the API. So normally, if you in C or something, if you had such a data structure, they're going to call malloc.
Yep.
And if you want to use this library inside your kernel or your Arduino or I don't know, WebAssembly or something, you don't get it because you can't call malloc in these cases, or you can, but you have to add a shim, right? You have to add like these weird glue codes,
right?
But with Zig, you actually just give the allocator that you want. So, on a desktop, maybe that is malloc. That's fine. You can pass that in. But if you're writing a kernel, maybe you have a kernel allocator that you're going to use, and you didn't have to rewrite your hash map data structure. You can use the one from the standard library. There's other really nice use cases for this, though. So as an example, we do have a global allocator that you are encouraged to use for all your unit tests. And this one will fail the unit test if there's a memory leak. So by convention, when you just run when you just run Zig test, you find all the memory leaks immediately before you even run your code.
Wow.
In as main application.
Now that you're saying it, it just seems so obvious.
Right?
Like, why would you have just one global malloc function that everyone is forced to use? But I always took that as like an assumption, like, malloc is special.
Right. And that's like I was saying, right? Like the big mission objective of the project is, all right, let's peel these layers off, let's examine their premises, and let's put them back together. But maybe we'll make some tweaks, maybe we'll change it, maybe we'll actually completely redo some of these layers.
So you were saying earlier that kind of the way you went about this is just take a look at the paper cuts of C, take a look at the foot guns, and kind of like address them one by one and come up with better and more elegant solutions. But now you're getting to things like passing in malloc, which I guess you could argue is you're addressing that particular paper cut, but that almost feels like less like fixing a paper cut, more like you've taken a bigger step. That's like a bigger thing. I don't know if I'm getting across what I'm trying to communicate here, but like, are there like these like more overarching principles or like these big design principles that you've extracted over time from this kind of like let's examine the paper cuts and fix them mentality?
Yeah, I think so. So we have this. I inspired by the Zen of Python, I created the Zig Zen, and I think that it maybe that could speak to the answer to this question.
Yeah.
So I'll give you one. My favorite one actually, from the Zen of Zig. It's avoid local maximums. That's the Zen principle.
Hmm.
And the analogy is with in math, when you have a graph, you have a global maximum, which is the best place to be.
Yep.
But over here, you have a local maximum, which seems like the best place to be if you get stuck. So you might be here, and you might actually have to go downhill to chase the global maximum.
Mm-hmm.
But that's what you have to do. That's our mission, right? We're not satisfied with, just close enough. Like, we really are willing to break things in order to put them back together in a better way.
Yeah. And is that applied to the kind of the evolution of the design of the language, or to like programs that are implemented in the language?
I think it's guidance for both.
Okay.
In terms of design of the actual language, it's kind of what I was saying earlier, right? It's a willingness to say, okay, we made this language feature, but there's a problem with it. We're going to break everyone's code. We're going to do version 2. We're going to try again. We'll still have time before we tag 1.0. We're going to use this time to continually reevaluate our assumptions.
I was kind of curious, how has the standard library evolved over time? Because, as somebody who's kind of dived in there a bit, obviously, like, a lot of inspiration has come from, I think, the Go standard library, just based on the way that kind of like the IO packages and stuff are structured. But in other ways, like, certain things have been omitted, like, let's say HTTP or something like that. So I'm kind of curious, like, is there, what are kind of the philosophical reasonings behind the way that the standard libraries ended up how it is? And, what do you see like the future of that being?
I think that right now, the status quo is that some parts of it are solid and some parts of it are a complete mess. The main purpose in the beginning, and still for the most part today, is that the standard library is a test bed for the language, primarily. So only after the language is stabilized will I think it's time to go in and take a hard, critical look at the standard library and say, what should a programming language standard library look like? And I haven't done that auditing yet. So it really is just like, what did I need while I was working on whatever I was working on? What did other contributors need whenever they were working on whatever they were working on? Who bothered to send a pull request upstream? Like, it's honestly a mess in terms of like curation perspective. A lot of the code is actually really high quality. When I say a mess, I mean it's just in terms of what's there and what's not there.
Got it. Okay.
Yeah. So specifically for web servers, HTTP clients or servers, whether that makes it in or not is yet to be determined. Probably, I'm guessing that whatever we need for the package manager will be in the standard library. That's probably going to be a consideration. And that probably means at least a client.
Mm-hmm.
But if you have a client, you probably need to test it with the server. So that might mean a server. So we'll see.
Is there a set of target programs that you kind of have in the back of your mind when implementing Zig? I think for a lot of new languages, the compiler, the self-hosted compiler is kind of the original target. For Go, I think one of the reasons the standard library has so much is that the creators were all at Google and they wanted it for this kind of like application, somewhat systems-y level programming they were all doing. For Zig, what is that target, if there is one?
Yeah, I agree with you that you can definitely see the intended use case coming strongly through in the Go language. I mean, it's almost admittedly made for like making servers.
Yeah.
For Zig, our tagline is a general purpose programming language and toolchain. Anyway, general purpose.
Yeah.
And it's a very intentional and ambitious statement, because it's saying, no, really, you can use this language for anything. And that's a large scope. So that's a big claim to make. But we're serious about this claim. So, and if you give me an example of any a problem domain, I mean, I can show you the way that use case is intended to be handled.
I see.
And it really is intended. So pick any use case it's intended that Zig will provide a way for you to optimally exploit your hardware to support that use case in a way that is like reusable, that you can use the same code for maybe it's a library. You can use the same code on even a different use case.
Got it.
We were talking about that earlier, right? Where you could reuse a hash map, for example, in a kernel in a desktop application. And it's the same deal. So as another example, so Go is really good for web servers, and they use what is it called? Green thread system, where it's like MN threading. And if you start a Go routine, it's like doing evented IO.
Yep.
So Zig actually has a way to do that. It's still experimental, but it's completely supported. So it, combined with the async await features of the language and a standard library implementation of an event loop, you can write code that looks a lot like Go code, in the sense that like you write a Go routine, like Go call function. In Zig you'd write async, and semantically it is doing the same thing with different memory layout. Like the stack is arranged differently. But semantically, you have an event loop, you have MN threading. It's the same paradigm.
Yeah.
But the difference here is that you can have a library in Zig that uses async await, and it doesn't rely on the event loop though, because you can have the same code compiled with evented mode on or evented mode off, and it works, like it generates the ideal code in either case. Got
it. So in that sense, if I'm understanding correctly, it does seem like a true successor to C then. Like I would say, unlike Go, for example, which was, as you said, like I think obviously targeting web server applications, or Rust, which arguably is targeting Firefox, or the next version of a web browser. Zig is closer to C in the sense that, like, when I think of C, I think of like, oh, they needed a programming language that served as an interface to like a Unix-based operating system, right? Like you had C and Shell as kind of the I guess in those days, like high level interfaces to the more lower level stuff. Like Zig is just, you're building this on top of the OS primitives, and you want to make the kind of full power and functionality of that lower level available to the user or the developer in a more accessible way. Would you agree with that statement?
I think so. I think you might be trying to make another point that I'm not quite understanding, but that all sounds like it checks out to me.
I was just trying to clarify my understanding, and really like place it, I guess, relative to those other languages too, maybe. And maybe that's a good segue, because I bet a lot of people listening to this are like, oh, when I think of modern, successors to C, like System Z, low level languages, Rust gets mentioned a lot. Stephen, I know you played around in Rust quite a bit, more than played around, wrote some, key services in Rust.
Sure.
Maybe we can talk a little bit about the distinctions between Zig and Rust.
Yeah, sure. Oh, is that a question for Stephen?
Well, probably eventually both. I'd be curious to hear, Andrew, from your perspective, what are the distinctions? And then maybe from Stephen, like, as a developer using them, what are the differences that you've seen? But yeah, let's start with Andrew.
Okay, so before I go give you a direct answer, I want to touch back on what you were just talking about a moment ago. So here's kind of a way I can maybe categorize some of these things. If you're writing C code, you're writing in the most straightforward way. You're writing blocking. Let's say you're writing desktop application C code. You're going to make OS syscalls. You're writing blocking imperative code, and like that's a well understood concept.
Yep.
If you're writing Go code, you're doing an event loop always. You're not doing the thing that you're doing in C. It would be very difficult to have a Go library that you call from C, right? Because the Go depends on a hefty runtime to do all the event loop stuff.
Yep.
So those are distinct. Rust supports both, So but there's modes. They're like different code bases. So in Rust, you can write the kind of C code where you have blocking imperative code and you make OS syscalls, or you can do like async stuff with Rust where you depend on Tokyo, or maybe there's another one. It's very pluggable, but then you're getting kind of like the Go thing where it's like the event-based thing, but it's a different code base, right? So the thing that's interesting about Zig is that, like Rust, Zig supports both of these use cases, but with the same code base. So you can have a library that both can be compiled for the Go use case and for the C use case. And that's the, I guess we call it colorblind async functions.
Got it. That's pretty cool.
But yeah, so I think that does segue into like what is the difference between Zig and Rust, because they're very natural to try and compare. Like what's the niche, right? And I think that there's two axes that you would perhaps pick up on. One would be the complexity of the language. So I think that, and the other one would be the strategy for safety. So going back to the complexity of the language, I would say that I think it's fair to say that as a language, Rust embraces features. There's more than one way to accomplish some problems. There's lifetimes that interact with traits, and that all interacts with I can't even remember, but there's just a whole bunch of language features, and they're all very handy. There's language features that you can use for like all sorts of different patterns. But it does give you overhead of just like thinking about becoming productive in Rust can take a long time, because you have to learn all these things. And if you're reading someone else's code and they use a feature that you don't know, you haven't learned yet, now you have to pause, go learn that feature, come back to the code. And that's fine. Like that's a strategy of, that's like I said, like when you read the no implicit control flow part on the Zig website, that's where you fork. Like, do you choose Zig programmer, or do you choose, no, I want more features in my language, right?
Yeah.
So whereas on Zig, the goal is there's only one way to accomplish anything, and there's a very small number of language features. You can learn all of them, and then whenever you're trying to read someone else's code, you never have to take a break to go learn the language. You can always just keep trying to figure out what the code does.
Yeah.
So that's the kind of complexity difference. And I mean, I'm obviously biased. You know which one I prefer.
Yep.
So that's fine. And then for the safety one, I like to explain it as kind of like vertical safety or horizontal safety. So Rust has unsafe blocks, and you cordon off entire sections of your code. You put a big like nuclear warning sign, like careful, nothing sacred is done here, or whatever. Right?
Here be dragons.
And you just try not to touch that code, and then everything on top of it, you're like, yeah, well, this part's fine. So in Zig, it's different because there's no unsafe keyword. You can't say like, oh, this is the code we don't trust. On any line of Zig, you could decide to cast an integer to a pointer and then load a value from it, and that is very unsafe.
Yeah.
But the thing is, it's a common misconception. Like people think that Zig doesn't care about safety, but there's so much work in a language that goes into safety. It's just everywhere. So when you do there's a pointer alignment checks, and if you do an alignment cast, that's safety checked. So like a pointer alignment is safe in Zig.
Yeah.
If you do integer overflow and you didn't use the like wrapping operator, there's a safety check there.
Yeah.
If you go out of bounds on an array, there's a safety check there. So there are some ways that you can escape. You can do something that is not detected in Zig. So for example, if you have a stack variable and then you take a pointer to it, and that pointer outlives the function call, that's not detected. Now we still have a lot of plans, so the language is not at 1.0 yet. We still have a lot of plans to add more safety checks, and that is one that I plan to address, use after free of locals.
Yeah.
Right now it's not addressed. But my point is that the safety is there. It's just kind of strewn around in different places, and it's much more granular. So for me, again, I'm biased, but what I like about it is that you can work on a project where you can't make everything safe. So for example, if I'm working on an embedded device and I need to do like memory IO, where I'm writing and reading from registers or something, I'm still getting protected. All the safety features are still activated for me. Even though I'm doing unsafe things, it's not black and white, right? It's like Zig makes unsafe code safer. Whereas in Rust, I would have to use unsafe, and then it's not granular. So I've just opted into the dragons all the way, you know? So that's I think that's how I would describe it, as kind of like vertical and horizontal safety strategies.
Yeah. It almost feels like an incremental approach, like TypeScript took with types in JavaScript, maybe at a high level, if you squint.
Yeah. And you know what? I'll even give it a downside, right? So the downside is that it does require some discipline as a programmer, and as we all know, programmers are not disciplined. So if you can make abstractions that just have foot guns in them in Zig, and then there you go. You're going to shoot yourself in the foot all the time because you put that into the abstraction.
Yeah.
But the language does give you the tools where you can make safe abstractions.
Yeah.
And so if you do that, then your code base will be safe.
Stephen, do you have thoughts here on like developer experience, Rust and Zig?
Sure. I mean, I think that for me, the really key thing is just that onboarding experience, that learning curve. In my experience coming, obviously going from Go for many years to Zig, I think is not a huge leap. Maybe, somebody from other language backgrounds would have a different experience, but, just the level of simplicity in that learning curve for me was really great. And I feel like I actually know, most of Zig, and I've only been working with it for, probably a few months now. But, I have worked with Rust code for, on and off for a period of, 2-3 years. And every time I jump into another code base, I'm like, oh, here's a whole bunch of macros. This is a kind of another concept in another language that I'm not familiar with. And so diving into foreign code like that, in my experience, has been really challenging. So for me, it really just boils down to that learning curve to be able to feel really productive and feel really confident about actually diving into other code. That's what I like.
Cool.
That makes me really happy to hear, because that's something that we advertise on the homepage, which is focus on debugging your application, not your programming language knowledge.
Yeah. From my standpoint, it shows through. I think it's
nice.
It's a pleasant experience.
So, having touched upon developer experience and developer productivity a bit, what about the other side of things, which people always ask about, which is, performance characteristics of the actual program? So, it's my understanding that Zig has recently moved to being self-hosted compiled, meaning the compiler is written in the language itself. Previously, the compiler was written in C, I'm guessing.
C++, but in a C style. We just have to do C++ because that's the LLVM API.
Okay. And so the key fact here is that it got a lot faster in going from C++ to Zig. So can you talk a bit about that, and how do Zig programs typically outperform C programs?
Yeah, I claim that Zig is faster than C, and I stand by that assertion. I can give like micro benchmarks of just examples of messing around with integers, and you can just see why the code that's generated is better. But I would also make the argument that just based on the principles of the language, the conventions that we have, the organization of the standard library, there's also just the results that in practice, Zig applications tend to be fast. And I would say faster than C, and I would even say faster than Rust.
Wow. Those are bold claims.
Yeah.
Why is that? Why are they faster? Like in theory, C is the lowest level, thing. How does Zig achieve better performance?
I have different answers for C and for Rust.
Okay.
So for C, I'll give you like one really small, simple example. So in C, there's this weird thing that if you use a signed integer, overflow is undefined behavior. But if you use an unsigned integer, this is in C. If you use an unsigned integer, addition overflow is wrapping. And in Zig, it's consistent. So in Zig, both signed and unsigned overflow is undefined behavior, or rather it's illegal behavior.
Yeah.
And if you compile in a mode that is allowed to exploit illegal behavior by assuming that it does not happen, then that would become undefined behavior. And then if you want wrapping integer operations, you have to use an explicit operation for that. And then you get what you want.
Got it.
So but my point, though, is that I can show you like a little Godbolt example, but if you're so C just doesn't have an addition operation on an unsigned integer that assumes it doesn't overflow. And the fact that in Zig, the optimizer can assume that will not happen generates better code. So that's like that's just an example of the kinds of language decisions that went into Zig that that backs up my claim.
Got it.
But yeah. But then also the thing that actually matters more is just the fact that having to pass around allocators makes you really conscious about how you're using memory and what strategies you're using to manage memory. And it opens up it makes convenient some patterns that are more efficient. So you could do all this stuff in C, you could do all this stuff in Rust, but people don't. But they do in Zig because that's the most convenient way to do it.
Yeah. I was going to add there, I think being able to swap out allocator implementations with something else and say, oh, hey, maybe I'm comfortable with this data structure using a bit more memory and, passing it an arena allocator or something like that. Like being able to experiment with different allocators really easily in a way that's not like, linking in a different global allocator or something like that, and being able to do that on like a per data structure level is pretty cool. And I think that has a lot of room for optimization of like memory allocation at a data structure level. I was working on Zig Glyph last night, which is like the Unicode package for Zig. And I saw that the author of that had like swapped out the general purpose allocator with an arena allocator and, got like 2 times faster speed on all of their benchmarks. So I think being able to play around with different allocators on a per data structure basis is a pretty cool thing that I haven't really seen in practice anywhere else.
That is really cool. Okay. Go ahead.
Go ahead.
I was going to say now do Rust, but
okay,
what were you going to say?
The same thing. I was going to say I'm going to do Rust now. So for that one, I'll circle back to the other example you brought up, which was self-hosting the Zig compiler and the speedups that it brought. So to be clear, the speedups that it brought are almost entirely from the fact that now I know what I'm doing, right? And it's the second version of something. You're always going to do better on the second version of something.
Yeah,
that's where those speeds come from.
Yep.
But I can tell you what I did right now. Like, what is the better thing that I did, and that therein, kind of lies the justification for my claim.
Yep.
So what I did is I learned about data-oriented programming. I developed a better intuitive model about how the cache system of CPUs work. And the fundamental premise is that or observation, I should say, is that if you touch less memory, then the CPU cache will get to have more hits for the memory that you actually do touch. That's the whole observation. So based on that observation, you can make a bunch of code changes, and then your code gets faster. So one of the ways that I did this in the self-hosted compiler was I found the place where we created a lot of objects on the heap. And the objects that we were creating on the heap were IR instructions. So this is a part of a compiler that is an intermediate representation that you use to pass from like one component of the compiler to another component of the compiler. You emit these intermediate instructions for the second component to consume. And it's code, right? So you're generating it. You're generating many of them in memory based on the code that the user types. So based on the observation about CPUs and this knowledge, my hypothesis is, okay, if we make these objects take up less memory, then not only will that just use less memory in the compiler, which is good, it will reduce the pressure on the cache of the CPU and therefore make the code faster. And this turned out to be completely true, and it ended up being something like a 35% speed up. But not only that, but that same big pattern, it was huge. And that pattern also existed in 3 other places. So I got that big of a speed up 3 other times for doing the same strategy.
It's always amazing to me, like the impact that just like increasing that cache hit rate or like cache locality, because you don't really cover it too much in computer science, as a subject, because it's all about algorithms and big O and whatever. But like man, that is a substantial speed up.
Yeah, it's more like it's more like computer implementation details 101.
Right.
Yeah. But let me make my point about with Rust though, because I do have a way to tie it in.
Okay.
So in order to do this optimization, this data oriented design reworking, one of the core components is a untagged union. So in Rust, these are enums, but they're tagged.
Okay.
And the thing is, though, it was very important to me to have there was a tag for this data structure, but you put it in a separate array, and that's part of the strategy. So you have one array up here, and it's just each one is a byte, and the byte says this is like the kind of instruction. It's like add, subtract, store, like whatever. And then in a different array, each element it contains the instructions data in a fixed size. So if you want to find out the tag, you go look up index number 1, and the tag is in this array. If you want to find out the data, you go look in the other array, index 1, there's the data.
Yeah.
This is called structive arrays. And the point of this is that if you tried to put all this data in one array, you would be wasting 7 bytes of padding, because if you only need 1 byte for the tag, but then you have like a pointer size field here, you have to have padding there. So you just put them in different arrays, and then like poof, padding goes away. And that's better for the cache, right? You're not putting padding in the CPU cache.
Right.
Total waste. So the problem is that you can't model this in Rust without unsafe. You have to use unsafe, which is fine. You could do unsafe, right? But no one wants to do that in Rust. No one wants to use unsafe because people come yell at you and make you feel sad.
Yeah, I mean it's called unsafe. That's a loaded word right there.
Yeah. So people don't do it, right? In practice, people try to write safe Rust code, but you can't fully exploit the hardware of your computer in fully safe Rust code. Yeah. So in practice, like these strategies are available to Zig programmers to write faster code. Yeah. And here's the kicker. This code is safe in Zig, because we have safety on untagged unions. Like we have both. We have, it's safe. Like
Got it.
We didn't have to give up safety to accomplish this, right?
And you were able to have that because you've taken this more incremental approach. Like you've been able to add this where like Rust, everything has to fit into this kind of grand,
exactly,
consistent, universal scheme.
So this is an example. I mean, it's one little use case. It's not contrived. It's a real use case. It's the Zig self-hosted compiler.
Yep.
It's a use case where if you try, it's safe in Zig, but if you tried to write this code in Rust, it would be unsafe or it would perform worse.
Yeah, that's very cool. We're almost out of time here. I wanted to cover really quick, are there examples of projects or organizations or companies that are using Zig right now? Anything, cool that people can check out and see?
Yeah, I would say I'll give you two answers to that one. So one would be an open source project to check out. Mm-hmm. It's called River. I think if you search for it, you'll come up. It's a Linux window manager.
Cool.
And that's written in Zig by Isaac Freund. And another project that might be fun to check out it's called Tiger Beetle. Let me make sure I have the right name here. Yeah. This is a up-and-coming financial accounting database, and there's a company behind this, and they're doing it in Zig. Tiger Beetle by Coil HQ.
Very cool.
Yeah.
On kind of a final parting note, if folks are listening or watching to this, and there's one thing that you want to ask them to do immediately after this episode ends, what is that thing?
Oh, is this to me? Sorry,
yes.
I got confused.
Yeah, that's for you. This is a final call to action.
Oh, a call to action.
Yeah.
Okay, you know what? I'm gonna beg for money. If you like what we're doing, we want to pay more volunteers. There are lots of people who are contributing to Zig, and they're doing awesome work, but we don't have enough money to pay them. And if we get more donations, we can pay them. Go to ziglang.org for that.
Cool. Go donate. I know I will.
Oh, thank you.
It's super cool, the work that you're doing, and thanks for spending the time today with us. This was very enlightening. It was super fun, and this just seems like a super awesome project. Thanks so much, Andrew.
Well, thank you for your time, and really nice to meet you, Stephen.
Likewise. Yeah, awesome.